Good morning, class. So today just want to talk about the integrating by separating the variables for AP Calculus. This one is very important. It's going to be guaranteed that's on the AP test, either for the Calculus BC or on the Calculus AB, but most likely it's going to be on the Cal BC test. So we'll do a few examples today. So the one with the special condition, and also the one that you have to state the domain, and also we'll do the one that it's the complicated one. So we'll take a look at some of the problem here. So let's start it off with the first one. So this one is actually coming out from the 2006 AP Calculus AB exam. So it's given with dy over dx for the differential equation. So we got y plus 1 over x, and where x cannot be 0, and with the initial condition of f of negative 1 equals 1. And also this one you have to state its domain as well after you differentiate it. So the first thing that we want to interpret is the differential equation. So this one is dy over dx, which is the derivative of y. And it's considered y plus 1 over x. So anytime they see the mix of the variable x and y, so the things that you want to separate them. So let's just cross multiply and see what happens. So dy times dx and dx times the quantity of y plus 1. So we got x dy equals y plus 1, the quantity of y plus 1 times dx. And also you may notice that x cannot relate it with dy, so we need to separate it out. So we need to connect that x and dx all together. So the way to connect them, so what we can do, we can just simply divide both sides by y plus 1. And also at the same time, you can divide it by x. And the purpose of doing this, we just want to group those differential with the like variable. So x got canceled here, so dx, well, just remain on the right hand side, but over here we got y plus 1 cancel. So we do have dy over y plus 1 on the left hand side. And then on the right hand side, we do have dx over x. And now from here, we can integrate it. So integrals of dy over the quantity of y plus 1, so we do end up with natural log of absolute value of y plus 1. And then for the integrals of dx over x, we do have natural log of absolute value of x plus c. Don't forget about the family c, because that is the indefinite integral. So now, in order to find out the value of c, we just plug in the condition. Again, this one is called the initial condition. So for f of negative 1, we do have 1. So let's plug in negative 1 and see what happens. So natural log of absolute value of negative 1 plus c. And then for y, it's also 1. So natural log of 1 plus 1. And the left-hand side will give you natural log of 2. And the left-hand side will give you natural log of 2. And the right-hand side will give you that natural log of 1 plus c. And then once you solve for c, so you just need to isolate that c as a variable. So natural log of 2 minus natural log of 1. And don't forget this one, we can condense them. So it's natural log of 2 over 1. It's a difference to quotient property of natural log, which is natural log of 2. Okay. So we write it. So we do have natural log of absolute value of y plus 1. So that equals natural log of absolute value of x. And then plus natural log of 2. And obviously this one, the right hand side, we can also condense them. So we do have natural log of absolute value of 2x, natural log of absolute value y plus 1, and then try to solve for y in terms of x. We take the base e on both sides. So we do have y plus 1, so that equals 2x. You probably want to put in absolute value as well, so that stays there. So try to simplify it a little bit further. So we do have y equals absolute value of 2x. And then if you try to separate it out, so this one turns out to be either minus 1 or plus 1. So it's going to be like a piecewise function. Okay? And now let's do another example which is similar to this one here. It's also integrating by separating the variable. Okay, so the next one I'm about to show you. So this one might be a little bit simpler compared to this one, but this one involved with a radical. So we'll look at that in a minute. Okay, so the next one is showing that as dy over dx. Again, differential equation, dy over dx, so that equals 2 over root y. So again, first thing you want to do, cross multiply, if that's possible. Okay, so cross multiply, we end up with root y dy, and then 2 dx. Again, radical form, we can always rewrite it as the exponential form. So it's y to the power 1/2 dy, so it equals 2 dx. Again, variable, they're already being regrouped with the like differential, so we can differentiate it both sides. So integrals of y to the power 1/2, again, using the power rule, we just raise up the power by 1, so we got 3/2 divided by 3/2, or in other words, that means multiply by 2/3. And then the right hand side, we do have integrals of 2 dx, which is 2x plus c. Again, it's indefinite integral. You cannot just simply forget about the value of c. The thing is that this one, there's no given condition. We just solve for the equations. So just solve for y in terms of x, and also with the value of c. And 2/3, so basically we can just divide everything by 2/3. So let's say this one is c1, it's just the first constant. And then once we divide it by 2/3, you'll end up with different values. So we got y to the power of 3/2. So that equals 2x plus c1 over 2/3. In other words, that means multiplied by 3/2. And then right here you want to distribute. So 3 times 2x, 6x. And then c1 times 3. So just leave that with 3c1 over 2. And then 3/2, we just multiply the power by the reciprocal, so it's 2/3. So the whole quantity to the power of 2/3. So that means y equals, this one should be reducible, so this one is written as 3x plus 3c1 over 2. So 3c1 over 2, that's just another constant, it's a brand new constant. So let's say this one is c, and then to the power of 2/3. And also this one can be written as y equals 3x plus c, and the whole quantity, q root, to the power of 2. So with the radical form. Okay? So now, the last example is going to be a little bit difficult. And also this one shows the initial condition. So we'll take a look at that in a minute. Okay? So anytime that I deal with the separating the variable, always try to integrate it, find the value of c with the initial condition, if that's given. And then normally it's also asking something else, and like a domain for the solution. Is that part of the solution set, or what it's invalid? So now here's the one. So dy over dx. So that equals negative xy over natural log of y. And this one is showing that y must be greater than 0, well, because that's the domain for the natural log function. So again, first thing that you want to do, if that's, well, we can cross multiply, we try to cross multiply, so we got natural log of y, dy, and then for the right hand side, we do have negative xy dx. Now you might be wondering, we got y dy all together already, but don't forget, there's another y on the right hand side. So we need to regroup all the y terms together. So the way that you want to do it, so this one we want to divide it by y on both sides. So now we end up with natural log of y over y times dy. So that equals negative x dx. And now at this moment, we just collect all the like variables into the same size so we can integrate it. So the right hand side is pretty easy to deal with. It's just negative x dx. So the integrals of negative x dx, which is negative x squared over 2. But don't forget, plus constant c. Now what about the the left hand side? The left hand side shows the structure of using the u substitutions. And you may notice that if u is y, or u is natural log of y, that means the derivative of natural log of y, it's 1 over y. So basically this one is just the integrals of u, okay? And that would be considered natural log of y squared over 2. And now, the way that we solve for c. So another thing that's given for the problem here, so it shows the condition. So the condition is showing that y equals e squared. Okay, y equals e squared. So when x equals 0. Okay, so from here we want to solve for c. So plug in 0 for x, so we do have 0 plus c. And then y, which is e squared, so natural log of e squared, quantity squared over 2. Okay. So now solve for c, so that means c would be this whole constant right here. And it looks like nothing we can simplify with the natural log of e squared. Looks like I can just bring down power. So 2, natural log of e, which is what? 1. So it's 2 squared, then that'd be 4 over 2. Okay, so natural log of e squared to the power of 2 over 2. So this one can be written as 2, natural log of e, and then quantity squared over 2. So, well, natural log of e, that's just 1, so we'll cancel that out. And then 2 squared, 4 over 2, which is what? 2. So the value of c, which is 2. And then we just want to rewrite it. So natural log of y, quantity squared over 2. So back to this step right here. And then that equals negative x squared over 2 plus 2. Now try to solve for y here. So multiply everything by 2. So we do have natural log of y, quantity squared. So that equals negative x squared plus 4. Again, we multiply by 2 on both sides. Exponent, so square, well, we just take the anti-square, so it's radicals, so square root both sides. So we do end up with natural log of y equals square root of negative x squared plus 4. And then the last step here, natural log. How do you get rid of the natural log again? So we take the base e both sides. So y equals e to the power of square root of negative x squared plus 4. And that would be the original equation. Okay? So thank you for watching the video today. So hopefully you guys can just read through the lesson. So just watch that from the first example to the third example. So any questions that you have, so we'll just put it on the comments. And thank you for watching the video today.